Okie dokie, let's see if we can make this work. So far, it's so good. Let's try you. That wasn't what I wanted, but we'll get there yet. There you go. Alright, that didn't work, I just pushed the wrong thing. Here I am. Alright, boys and girls, I think we're starting to roll here. I'm testing you. Let me see. If this works, we're definitely rolling. It worked, hooray. Okay, what do I need to do? I think what I need to do is go up to this one and fade me in, and maybe the music will sync. And I think it is. Oh, what do you know? All right, I'm not going to hear the music once I put down the headphones. So, I'll do that. Hi boys and girls, it's me, Butch. My name is Terry David Silvercloud. I'm not native, just sounds that way. Today is, I gotta make sure we're working here. I think we're working. Oh, cool. We're working. So today is the 1st of March, 2025. It's Saturday. I told you my name is Butch, Terry David Silvercloud. And make sure I get the right camera. There you are there. That's really weird. Oh, I see. I'm learning, I'm using you. So I'm recording this with Open Broadcast Studio, and I'm a photographer by trade, but I don't know a lot about sound recording. I'm into physics and I know how it works, but I'm trying to make all the sounds work when you're transitioning between scenes and all. That's a feat. So let's get going here and stop wasting time, Butch. That's me, Terry David Silvercloud. Google Butch himself. And what's happening is I'm 80 years old, and in spite of however I look, I have very, very, very serious problems with the ticker, and I could keel over while I'm actually doing this, but probably won't. So I have two issues. The first issue I've been addressing lately since December. You may see spots in my body. I have hormone issues, and my hormones got out of line. I got some ingrown hairs. They're healing, I hope. I'm so vain that I want them to be better for summer at the beach. Anyhow, my hormone levels are being adjusted. I'm seeing an endocrinologist and have been for nearly 12 years. I'm in pain management, but because I developed heart problems, they're worried about my hemoglobin, and my warning to you, all you dudes who are over 40, is asked to have your hormones checked whenever you do some sort of physical. I know my audience is coming from all over the world. Hi Mohammed. Hi Manuel. And right now I'm quite concerned. I'm Canadian, and the old Trumpy poo, the dictator down in the States, is threatening to take over our country every day and insulting our Prime Minister constantly. So I'm in Canada. I'm a bit safe for now, but I'm concerned about all my American LGBTQ viewers and stuff. Let's give you another camera here. What am I on? Let's go to camera 2. Over here, give you a different view. There you go. I think I'm on camera 2. Way to go. All right. What's his name? Trump. He's a real threat to the LGBTQ community, and he's already been going after apparently employees that he finds are. You get my drift, I hope. I'm such a yacker. Hang on, I have a dry throat. I'm learning how to use OBS, and I'm trying to get all my sounds and things synchronized. And if you've never done it before and you try, it'll take you a while. Eventually you'll get it. and I'm going to next time work out how I can hear the sound and talk and not get feedback. I figured out a way to do it. Now I just have to do it. So while you're here, I know you're from like all over the place. Let's go to camera 3. I think that's you guys over there. Guys over there and girls too. What was I going to say? I want to teach you things while you're here. Well, that's what I was going to say. I know that a lot of you come here to just say like, who is that old guy? Like, what's going on with him? Like, is he weird or what? Yeah, that's good. If you're thinking weird, that's good. I like to call myself queer because I don't quite fit into the regular gay community, and that's because my sexual preference is twinks and younger men, chicken. When I was younger, my friends would call me a chicken queen. That's sort of old school gay slang. I don't know if it's still going on now. It's getting easier to be LGBTQ now in the Western world. I'm not sure about what with Trump's going on, but when I was coming out, it was against the law to have sex with your own sex. But I did have a, let's go to camera, that's French for 2. I think I can see it. Let's see what I'm seeing. Now let's go to camera 1. So this, see, I can see what I'm doing here. That was my boyfriend. He died in 1994 from complications due to AIDS. This is when he was about 21. I met him when he was 19, about to turn 20, I believe, and I was 31 around there. So this is a long time ago. That was my boyfriend, and I don't know where I'm going with this. Oh, that's, when I met him, I just felt like instantly, I fell so instantly in love with him that I picked him up on the street. Somebody had punctured my tires. I don't know who would know it was my van. Maybe somebody in the neighborhood knew I was a fag and punctured my brand new tires that I had yet to pay for, which back in 1976, $400 was a lot of money to me. So I was going over to meet my older lady friend Norma, who lived a few blocks away, and on the way I bumped into my future boyfriend Mark, walking towards, and he turned. So I had my dog with me. I just started following him, and he circled the blocks, and I thought, what's with that? And I followed him, and he started hitchhiking, which was common in Vancouver. He was back on the main street again where I first saw him. I asked him to come home with me and let him perform functions upon him, and he said, okay. And the next morning I said, I can't let him get away. I can't. It's gonna make me cry. So I asked him to be my boyfriend, and said, and I had only known him that one night, and this is the morning time, and said, there's going to be 2 rules. You're 11 years younger than me, and I know you're going to screw around on me, so I don't want to know. But at night we always sleep together. But those are the basic rules. We always sleep together at night, unless it's been rearranged, and I don't want to know if you're screwing around, because I know you're going to. It's just going to happen. I want you to be my boyfriend, as in forever, please. And when I came home from work a couple nights later, he was sitting on the front lawn in the house where I had a room, and said, okay. And I spent the night at his place, and then he moved in with me. And that's the picture I showed you. That's where we were living. Okay, enough of that. While you're here, I want to teach you a little bit about quantum physics. So in order to do that, I have to go over to my computer and change the screen. So hang on, bear with me. If everything works out, you're going to see a different screen here. And so Microsoft has announced that they have come up with their own quantum chip. And the big picture, I'm not sure about the picture in the lower left, but I think that's a really microscopic view of really in there. I'm not 100% certain, but up in the main left side of your screen there is a picture of their chip, and to make it work it has to be kept at like pretty near freezing, but that's common. So I thought what I would do is try to teach you a bit about how these suckers work. So I can't see my screen very well, but down in the lower right, down there I think, you'll see some different ways of detecting a current. A current is when an electron moves through a conductor. When an electron is moving, that's a current. And in these computers, they want to measure one electron at a time. And so the really good computers these days, the chips are measuring one electron at a time. So they've gotten pretty good at doing that. And what would happen in a normal computer chip transistor, and there's thousands of them, it's just basically an on-off switch, and it works on little teensy-weensy little magnets called the field. When the electrons are spinning, they're creating a magnetic field, and the wires, because they're either positively or negatively charged, they're either missing electrons or they have too many. All of these three things interact, and that's how a normal transistor interacts. So in a quantum computer, there's different methods that they've cooked up to do that. Somewhere I put a pole. Now I've lost it. How could I possibly lose my pole in here? There it is. So what Microsoft has done, I think, I've been teaching myself, I'm into particle physics. Lately I've been studying, what's with these quantum computers, and so now that meant I had to get further into quantum physics. I'm into particle physics, and we're going to get to Butch's theory of everything really quickly before I finally shut up. So what Microsoft claims to have done is they claim to have been able to stack atoms. If you can imagine atoms stacked back to each. This pipe is a whole bunch of atoms, not molecules, actual atoms. It's in the patent. I don't know what it is. I have some pretty good ideas what they've done to blend, but let's not get into that. It's complicated. But anyhow, what they claim to have done is be able to manufacture a string so fine that only one atom at a time can get through, and we know we can do that these days. And along the way, normally if this was the chip, the off-on transistor at the end, all they've done is they put the wire that's connecting that transistor to that gate down there, they stretched it a weensy little bit. This is so tiny you can't see it in there. It's so tiny. These are atoms apart. If it was floating in the air, you start having trouble seeing. It's that small. So what happens is if this, the camera mod here, one. So if this here is an electron, and in order to get from the gate in the transistor to the actual working, the old bit on the end here, it's going to be off or on. Whether or not, if this gate opens and nothing comes through, then a current can go this way. But if this gate down here in a regular computer opens and a whole bunch of electrons come down here, the electrons that want to go that way, they can't. They're being resisted by the magnetic fields of the electrons in here. So what we're going to do in the quantum computer, one way to figure out how to do it at near absolute zero, this electron is going to travel at the speed of light down this wire, and it may have 50 atoms in it. I don't know how many atoms. It looks like it may have several thousand atoms. I don't know, but the point is there's a whole bunch of atoms stacked up end to end, and for this electron to get from the gate, each time the gate set by the computer is opening and shutting, in order for it to get down to the gate, it's going to have to go through these atoms. And Microsoft claims to have come up with a way to, I thought I was on that camera, sorry people. Microsoft claims to have a way of using the surface area, the topological features of the particular atoms they've chosen, which is probably either an electron on one side and a hole on the other side, or two. This is complicated stuff, let's not worry about that. But for the electron to go in the wire up here, I'm going to grab it, oops, and come out the other end here. While it's going along here, they have already made it face a certain way. I don't know which way, flat or side, whatever way they decided, and it's probably, remember this is a ball actually going through, not a flat thing. So I only used the flat thing, forget that it was flat. They used a ball, but if you can see that there's an equator and there's a north and south on here, they've probably, and they would, I'm sure they would align the poles of the electron so they're going north to south or south to north, whatever they're doing, and the spin, which direction the electron is spinning when it enters here. So they know that the electron is going to enter, say, north pole forward into this wire, and it's going to be spinning to the right while it's passing through the wire. If while it was going through the wire, don't worry about that. Remember there was a transistor down at the end here with an off-on gate, which is your regular computer off-on gate, opening and shutting as fast as the clock is making it open shut. But whilst that electron in Microsoft's computer was traversing the wire, they placed at very critical angles along the way pretty much the very same thing that's down at the end here. But they put them around the wire at different angles than this one. So what that means is that, oops, gotta go get my electron. Come here, boy. We need it. So what that means is, as the electron was spinning by the sensor, where'd my sensor go? Here's a sensor. Remember, we're going through a wire here, and there's sensors here, there's sensors here, there, and they're spread along the wire. Each one of those is acting like the sensors down at the end, the gate down at the end, and because the ball is spinning, it won't be at the same spin when it passes the sensor, just like a car going down the highway with the cop with his radar gun. They're never going to be all exactly the same. He'll get the speed right, but if he had a really good physics gun, he could also tell how fast the car was spinning and get a picture of it. And you could use that to add additional off-on gates, just like it had an off-on gate at the end. So if you could have in your wire, for every off and on that was happening down here, when the gate opened up here, you could also get, depends on your engineering, 50 other gates that also opened at the same time. Basically, we're talking the speed of light here. Then you could increase your computing power by, one wire was 50 times. That was just a bit, and we work in bytes. There's already 8 of them. So 50 times 49 times 48 times 47 times 46 times, are you catching the drift? The computing power would be increased like incredibly. Okay, that's your explanation of quantum computing. If you didn't get that, well, come back and watch it again. Sooner it'll make sense. I know the geeks and the nerds said, oh yeah, it makes pretty good sense. Thanks, Butch. If they didn't already know before, now you know how that's the string type of quantum computing. Well, do you know what I didn't do? I forgot to change screens. I keep thinking I'm seeing a big screen. Well, you can see me down the little screen down there. I gotta do a few things here just before we leave, because I was supposed to do this while I was yakking at you. What do I want here? On this one here, Microsoft picture, I wanted to show you a couple other pictures if I could do it. They should be turned off right now. Jesus is silly, David. Crap. Let's turn you on. Okay, that's what I want to do. So, before I leave you about the quantum computing, originally, because I was talking, if you're a geek, you already know about bits and bytes, but if you don't know about bits and bytes, back in the Bill Gates days when they decided, they have, quick history of computing. One of the big manufacturers commissioned Intel, geez, I should know this off my head, maybe I'll remember it, to make them a little tiny computer chip for future washing machines and things, and eventually he said, oh, we're not going to do it that way, forget about it, you can have it, just help pay for it. So in Intel's stockpile of stuff, they had the 8-bit chip. It was a little chip that could turn 8 things off and on at the same time. That's all it does. And so Bill Gates and his friends and a whole bunch of other geeks around the world said, oh, we can make a computer of that. So they would make their own computers. They would just order these chips from Intel and build their own little various types of computers. Bill Gates being one of them, and the rest was history. He had friends too. But anyhow, that 8-bit chip produces a byte, and the way you can rearrange all those off-on things are the basic 8 times 7 times 6 times 5 times 4, and you can see on the screen there, I hope you're hearing me, I hope you are, let's see if I can check, make sure you're hearing me. Are you hearing me? Yeah, it's kind of echoey. Sorry about that, I'm still working this on. That's how many different characters you can put on a 8-bit thingy. So let's go back with this thing here. You'll see all of me. That's what you really want to see, right? That's what you came for. You want to see all of me. You could try my homepage at butchboard.com while I'm still alive. That might work. Did I say that? I do have a homepage at butchboard.com. That's all you need to know. You'll figure it out. So I taught you about how a quantum computer works. Now, because this is already probably horrendously long, and if you're a geek or a nerd, or I have no idea why, you're still here. Before I stop, I'm going to run you by my theory of everything. I have to clear my throat. Hang on. I think it's working. All right, Butchie Pooh's theory of everything. Just let me catch my breath here. There we go. 15 pounders. Don't try this at home, kids. Which camera am I on here? I'm on camera 1. You guys over there. So I'm on camera 1. So Butchie Pooh's theory of everything is that matter, the solid stuff, relative to us who live in the world of Einstein's world of general relativity, this stuff is moving at the speed of 4/3 pi c cubed. You know that Einstein said energy is equal to mc squared. So what that is energy is equal to the mass, whatever it is, 1 pound, 10 pounds, 100 pounds, 1,000 pounds, times the speed of light squared. That is giving you like the area of a circle. And it means that it's able to be everywhere on that plane at the same time. So Butchie-Poo is going to tell you how it can be not only at the same plane, but in the same sphere. This is within the realm of quantum physics. In quantum physics, what they do is they can give this thing polarity, a north and a south pole, and they do, and they can give it like spin, and they do. But all of that stuff is based on the speed of light squared. So quantum physics, because it works at, you keep seeing c squared, the speed of light squared, it'll just pop up because, not that it's in the actual formula, but the formula, it's like algorithms, that's how it works. The geeks will get it. So anyhow, Butchie-Poo is telling you that we live in the world of relativity, and for you to see something, for me to see, I gotta see what's on the screen here. For me to see this ball, the light will come to me at the speed of light. It came in at the speed of light, it hit me at the speed of light. If I shine a radar or laser at it, the time will take, because I'm going to measure how far away it is, I'm going to have to divide how long it takes in two, because it's got to go there at the speed of light, then it's got to come back at the speed of light. So we divide by 2, and now we know how long that took, and then we can figure out how far away it is. So, but you say, but I'm seeing a whole ball. You see, and the physicists say, well, that's okay, because all these different things are coming at you from wherever the light hit them at the speed of light. Well, what's your problem? I said, well, how does it get to be there and there and there and there at the same time? So Butchie-Poo is going to tell you. It's traveling at 4/3 pi c cubed. You see, what the hell is that? What that is the formula for the volume of a sphere. So if a singularity, physicists don't like talking about, quantum physicists, it's just a singularity because that's how it works, because they're measuring how fast that singularity is moving. To have one quantum, and the singularity has to spin once, and let's not get into that. But and they turn it into a ball by turning it into a wave. But they're still measuring it at the speed of light. So that's okay for measuring, but still, how did it get to do that? So if it could travel if we just changed it up to the whole lot, to 4/3 pi c cubed, it could be here, 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 here. What camera am I on? You guys over here. It could be here, 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 all at the same time. So that's Butchie's theory. All right, you won't get any fake news here. If I'm telling you something, you're not going to get any bullshit from me. If it's my idea, I'll tell you it's my idea, and you can say, no, he's wacko. Until you know as much as I do, well, the nerds will get it. Butch likes to call himself Socrates because he really admired Socrates. Socrates had to kill himself rather than renounce his views. And he was ordered to do that, or renounce his views, which were that the gods were all a bunch of hooey. And that didn't go over very well with the priests and the very conservative upper class, because that's how they kept people in line. They were democratic, but they still had their gods, and you don't offend the gods, so like you apologize to the gods. And the big problem was, aside from being really annoying, and he apparently said he knew nothing, he was always asking endless questions. He spent a lot of time at the taverna outside the Agora, which was the marketplace, and the young men weren't allowed there. And so he hung out there. He was gay, I guess, and so were a lot of the hookers that hung out there, and male hookers plus young men. They just it was sort of a thing with the gay men, you know, because they were into bonking younger guys, as I understand it. That's what I was told. See, I'm telling you, that's what I was told. Everything I checked seems to confirm that. And archaeologists have recently found what they think was the Taverna location, and they're carefully, you know how slow it is with them, excavating it. But Socrates would hang out there, and he apparently was telling the young men that the gods are all a bunch of hooey, and you want to come on with me, that kind of thing. And he was in, I don't know what he looked like, but apparently he was in, he didn't write much of anything, but his followers, you know, Socrates and Plato and those kind of people, from what they said, he said that he was into physical fitness and stuff. So has Butch gone on long enough now? Probably. I'll test some cameras out here. I'll try camera 4. What is camera 4? Oh, this is my space. I'm an artist in my old age. I don't know if you can see me or not, or hear me or not. This is my, that's where I do my, my painting work. And, oops, falling all over my Crocs here. This is getting really long, isn't it? Are you still here? So thank you to all my mini subscribers. And this is all just me trying to work how to make the sound better. And for those of you that came here to check me out, here I am. I'm 80 years old. My birthday's October 24th, 1944. I've been in hormone and pain management for 12 years. I take 6 heart pills a day. I hurt a lot, have trouble sleeping. So life is not fun. I know a lot of my audience is older guys, but for you younger guys, or younger than me anyway, a lot of the people I grew up with, they're dead. So that's what I'm trying to tell you, that statistically, probably half of you won't ever live to be as old as I am. In North America, only about 20% of men live to be over 80 years old. So that's 1 in 5. It means the rest of you are all dead. Sorry about that. I didn't plan to live this long, but it sucks in its own way. But I hate. Here's something I'm working on. Oops. Come here, boy. This is something I'm working on. And I'm gonna shut up now. I think I covered what I meant to cover. I wanted to teach you a bit about how a quantum computer works. And I have other things I wanted to talk about too, but I didn't get around to it. So I'm going to work my way back over to my computer here. What camera am I on? Camera 3. Let's go to camera 1. Let's try camera 2. Camera 2. La deuxième. Am I on 2? Nope. Camera 2, please. Okay, let's go back over to the camera 1's good. 1. Bye. And what I am going to do is I'm going to sign myself out. So it's been fun. I'm going to click a few buttons and fade away. Bye. Here we go. I got to go up here and go click.